6 from Pure Math 4 Pearson Edexcel A-level exam. This exam was taken in January 2024. Relative to a fixed origin O, the lines L1 and L2 are given by the equations. L1 position vector for line L1 is given 3i plus 5j plus 7k plus lambda into 2i minus 5j plus 4k. L2 r equals 8i minus 2j plus 5k plus mu into 4i plus j plus 2k, where lambda and mu are scalar parameters and t is a constant. Given that line L1 and L2 intersects, find the value of p. Two position vectors are given. Let's say this is position vector for line L1 and this is position vector for line L2. Best thing to write the vectors or position vectors in the column vector form. Okay, so we can change this one as write the coefficients of I, here 3 and there 2 lambda. So we can write as 3 plus 2 lambda. Okay, then p minus 5 lambda, p minus 5 lambda. Same way for case 7 plus 4 lambda, 7 plus 4 lambda. So this is the column vector for this position vector. We can write the other position vector as column vector as it will be 8 plus, here is 8 and here 4 mu. So we can write as 8 plus 4 mu. And the second minus 2 plus mu, minus 2 plus mu. Same way for third, it will be 5 plus 2 mu. So these are the position vectors for line L1 and L2. Okay, the drawing diagram is not compulsory. This is just only to let you understand. This is line L1 and this is line L2. Okay, this is called the starting point. Any multiple here, this is called the direction vector. Okay, let's say this is the direction vector for line L1. So we can represent the direction vector as dL1. This is the starting point and this one is the direction vector for line L2. So we can write as dL2 here. Direction vector represents the direction of the vector. Okay, for example, direction of this vector for L2 is this way. This is not according to scale. This is just only to let you understand. Okay, so we can say the direction vector for line L2 is dL2 this way. Okay, and direction of this one is dL1. So these are some very important things you have to understand about the vectors. Hopefully you got it up to this. And this is the point of intersection. And let's say this is the origin. If they are intersecting at one point, so the distance of this point from the origin will be the same, you know, for both vectors from here to here. Okay, this is the position vector of this point of intersection, this one from the origin. Hopefully you understand it. Okay, at this point this r1 and r2 will be equal. So in this case r1 vector will be equals to r2 vector. That's why we are writing r1 equals to r2. Hopefully you understand up to this point. To save time, I already wrote here these two position vectors, because we want to find at the point of intersection, we want to find the p. They are intersecting, therefore we can write as at point of intersection r1 vector will be equals to r2 vector. So we can write these two vectors to equal to each other. That's it. So it will be 3 plus 2 lambda, p minus 5 lambda, and then 7 plus 4 lambda will be equals to 8 plus 4 mu, and then minus 2 plus mu and 5 plus 2 mu. Equating both sides, i's will be equals to the i's here. This is the coefficient of I, so we can equate them. Okay, so we can write as 3 plus 2 lambda equals to 8 plus 4 mu, and you can make equation, bring the variables towards left. So 2 lambda minus 4 mu will be equals to 5. 3 goes towards right, so it will be minus there, so 8 minus 3 is 5. Equation number 1. Now we can get the equation 2. It will be p minus 5 lambda is equals to negative 2 plus mu. P will be equals to, because we want to get the value of p, so it will be equals to 5 lambda plus mu minus 2. Now the third equation we can write as 7 plus 4 lambda is equals to 5 plus 2 mu. This is your equation number 2, because we want to get the value of lambda and mu also. So solve these two equations together. Best thing, bring the lambda and mu on one side, so it will be 4 lambda minus 2 mu is equals to 5 minus 7 is negative 2. Because here coefficient of mu is 4 and here coefficient of mu is 2, so best thing, multiply this equation by 2. Okay, we will get here 8 lambda and minus 4 mu equals to negative 4. So this is your equation number 3, and then we will put the equation number 1 below to this equation to get the value of lambda from here. Now the coefficients are same, so we will subtract these two equations and we will solve them, okay, simultaneously. So change the signs, we will subtract these two equations, cancelled out. 8 minus 2 is 6 lambda, and this is equals to negative 9, and lambda equals to divide by 3 both sides, so it will be negative 3 by 2. So answer of lambda is negative 3 by 2. You can put this equation in equation number 1. Just replace this lambda with negative 3 by 2. So we will get here minus 3 by 2 and minus 4 mu, keep as is, and then 5. Bring this 4 mu towards right and then 5 towards left. 2 is cancelled out, and minus 3 and minus 5 will be minus 8, and this is equals to 4 mu, and we get the answer for mu as minus 2. Divide by 4. Use these two values in equation number 2. Therefore we can get the value of P from here. 5 into lambda is minus 3 by 2 plus mu is negative 2, okay, then negative 2. This will be minus 23 by 2. So this is the answer for P. Hopefully you understand the first part. For second part, find the position vector of the point of intersection. This is the point of intersection, okay. So at this point R1 and R2 becomes equal, okay, then you will find the position vector. Plug in the values of lambda and P in this equation, you will get the position vector for point of intersection. And if you plug in mu only in this equation, then you will get the position vector for point of intersection. That is your choice, what you want to do. So best thing, I am choosing this one, okay. Position vector for point of intersection is, so I'm writing the second one, okay, where mu equals to 2. It is negative 2. The 8 plus 4 mu and then negative 2 plus mu and then 5 plus 2 mu. Plug in the value of mu here, so it will be 8 negative 8, and this will be negative 2 negative 2, and this will be 5 negative 4. So answer will be here 0, this will be negative 4, and this is 1. So you can write in vector form like 0i, no need to write, so you can write here minus 4j or plus k. So this is the position vector for the point of intersection. Second part is done. Now for C, find the acute angle between the line L1 and L2. We know that here they are making angle theta here, okay. This is the angle theta, acute angle. There is the acute angle and the other one is obtuse angle, okay, point of intersection. This is direction vector for DL1, and I already told you this is the direction vector DL1, okay, and this is the direction vector for DL2. Let me write these direction vectors here. Okay, so first direction vector will be for C part DL1, direction vector for line L1, that is 2, negative 5 and 4, and direction vector for line L2 is, I'm writing in column vector form, that is 4, 1 and 2, 4, 1 and 2, okay. Let me get back, then I will show you what is from where we can write the direction vector. This is the direction vector for line L1, okay, this one, and this is direction vector for line L2. So I wrote these two direction vectors. Just direction vector decides which direction vector is going on. If you take the dot product of these two vectors, if you remember the dot product formula, we can write as d dot product of d1 and dl2 is always equals to dl1 vector magnitude and then dl2 vector magnitude of the other vector, and between them the angle is cosine theta. Okay, the angle between them is theta. So this is the formula. If you remember, if you want to write the formula for vectors between two vectors, dot product is always equals to ab cosine theta. This a is the magnitude of vector a, or you can write this way. There is no difference between writing this is the magnitude of vector a, or you can write as without vector sign. Okay, so there is no difference. Now we will take the dot product of these two vectors here. You know how to take dot products. This is 2 and this is -5 and this is 4. In dot product we can multiply I with I only, j with j and k with k. Okay, because I and if you multiply I with j, that is 0. Dot product is 0. Okay, because I j cosine theta, cosine between I and j, the angle between I and j is 90. That's why it will be 0. That is a long discussion. You must know we multiply I with I, j with j and k with k. That's it. Then how to find magnitude of dl1? We take the square of all i's, j's and k's. Okay, square of them. Okay, and take square root. And then we take square root of the other one. It will be 4 square plus 1 square plus 2 square cosine theta. Here you multiply 2 with 4, it will be 8. Minus 5 with 1, it will be -5. 4 with 2, so it will be 8. Solving this one into the square root, 2 square 4, 4 and 25, 29. 29 and 16. 29 and 16 is the 45. And take square root of this. 4, 4 plus 1, 5, 5 plus 16 is 21. Cosine theta. Okay. Now multiply 21 with 45 and take the square root of this answer. This is 3 square root of 105 cosine theta is equals to 8 plus 8, 16. 16 minus 5 is 11. Okay. Then cosine theta will be equals to 11 over 3 and square root of 105 and take inverse of this angle. Cosine inverse 11 over 3 square root of 105. That's it. Okay. Cosine inverse 11 over 3 square root 105. Get your answer. Your answer is 69.0 degrees. 2, 3 significant figures. Okay. Theta will be 69.0 degrees. You have to write your answer to 3 significant figures. So this is the answer for part C. For the third thing, find the acute angle. It is already done. Give your answer in degrees in 1 decimal place or to 1 decimal place. That is also, and also in 3 significant figures we are writing the answer. Anyways, the point A lies on L1 with parameter lambda equals to 2. Okay, again this is line L1. Okay, let me change the color so it will be more easier. This point A is here on line L1. Okay, this is point A. Okay, so lambda value is 2 and we already got the value of P, that is negative 23 over 2. Okay, and but that point, for this point A, the value of lambda changes and that point lambda is 2. Okay, when it is at A. The point B lies on L2 with the AB perpendicular to line L2. Okay, this one B is here, somewhere here. Okay, at line L2. This is B and it is perpendicular to this point B. Okay, this vector representing the position vector for B. Okay, that's it. So this line AB is perpendicular to line L2. For A, we know the value of lambda, that is 2. and we already got p is negative 23 over 2. So we can use this vector, this one. Okay, so I'm writing that vector there, 3 plus 2 lambda, p minus 5 lambda, 7 plus 4 lambda for the last one. Okay, at a uh, at a position vector for a is, that is represented by OA, and this will be equals to R at a, and value of lambda is 2. Okay, we know the value of p is negative 23 over 2. We already got it. Okay, p remains constant, it will not change, but lambda will change for. So this will be equals to R1, and we can use this R1. Okay, here 3 plus 2 lambda, p minus 5 lambda, this one. So it is 3 plus 2 lambda, p minus 5 lambda. I'm writing as is, so it will be easier for me. 7 plus 4 lambda. Okay, plug in the values, we will get the position vector for OA. For that question, actually, let me read this question again. Find the coordinates of B. Actually, we need to find OB. Okay, position vector for B. Once you find OB, you could find the coordinates of B easily. Okay, that's it. So 3 plus 2 into 2, p is negative 23 over 2 minus 5 into 2, and then 7 plus 4 into 2, and we get the position vector for A. It will be 7, negative 10, negative 2, 20, 20 and 43, negative 43 by 2, and this will be 8 plus 7 is 15. So this is the position vector for A. Okay, and we know that the position vector for B is OB, and that is equals to, we don't know, we don't have the perimeter, mu is unknown here. Okay, we write the position vector for the line, other one, that will be equals to R2. So I'm writing here R2. Okay, and this will be equals to, because B lies on line L2, that's why it is R2. Okay, 8 plus 4 mu minus 2 plus mu 5 plus 2 mu. OA and OB is given, so we can find AB. We know that AB vector is equals to always B minus OA, position vector of B, OB the second letter. Okay, minus the first letter. Okay, plug in the values for OB. OB is 8 plus 4 mu, and this is negative 2 plus mu, and this one is 5 plus 2 mu, minus OA is 7, and then negative 43 by 2, then the last one is 15. Solving, 8 minus 7 is 1, so it will be 1 plus 4 mu, and minus 2 plus 43 by 2. Solve it. So we will get here 39. Okay, for negative, and it will be 39 over 2 plus mu. Okay, 39 plus 2 mu, and the last one will be negative 10 plus 2 mu. Negative 10 plus 2 mu. This is the value for AB. This is the column vector for AB, vector AB. And again, if you notice that AB is perpendicular to line L2. Okay, AB is perpendicular to line L2. This thing is given. Given that AB vector is perpendicular to the direction vector for line L2. Okay, line L2 or direction vector of line L. So we know that direction vector for line L2, if they are perpendicular, we know that for perpendicular vectors, if A vector is perpendicular to B, then their dot product is always 0. A dot B equals to 0. According to the formula, AB cosine 90, 90 is 0. So this is the rule. So we can take the dot product of line AB and direction of vector for line L2. Okay, this should be 0. AB we just got it, that is 1 plus 4 mu. So I'm writing here 1 plus 4 mu, and the next one is 39 by 2 plus mu, and the last negative 10 plus 2 mu, negative 10 plus 2 mu, and direction vector of line L2 4 1 and 2. Okay, 4 1 and 2. Let me make it clear again. This is 4 1 and 2. This is direction vector of line L2. Okay, this one. Hopefully you understand it. This is long question. Anyways, you must know each and every step. This will be equals to 0. What I did here, I just plug in the values, okay, for AB and direction vector of line L2. Now in dot product we multiply I with I. So 4 will multiply with the first value 4, then 16 mu, okay. Then 1 will multiply this, so we'll get the same answer, 39 by 2. It is plus mu. Then 2 will multiply the last one. So it will be minus 20 plus 4 mu equals to 0. From here we will get the values of value of mu. 4 mu plus mu is 5 mu, 16 and 21 mu. Okay, so it will be 21 mu. And solving this, all these numbers, negative 16 and 39 over 2 gives you 7 over 2. Okay, so it will be, if you bring that value right side, so it will be negative 7 over 2. Okay, 21 multiply here, so mu will be equal, so mu will be equals to negative 7 over 42. Simplify these numbers, so we will get the answer for mu, that is minus 1 over 6. Okay, now we can use this value in OB. Okay, the second vector, this one, for mu, 8 plus 4 mu minus 2 plus mu. Okay, so OB will be equals to 8 plus 4 mu minus 2 plus mu and 5 plus 2 mu. Okay, use the value of mu here, 8 minus 4 over 6, we use this value here. Okay, mu minus 2 minus 1 over 6, and then 5 plus sorry, it will be minus 2 over 6. Okay, hopefully you understand what I'm doing. I'm replacing the value of mu here and solving it. Get your answer from here. 8 minus 4 over 6. Better if you use calculator here. Okay, so it will be 22 over 3, and second one will be negative 13 over 6, and the third one will be 14 over 3. So this is the position vector for B. Therefore the coordinates of B should be written in the other form like this. The coordinates of B will be 22 over 3, then negative 13 over 6 and 14 over 3. So this is the answer for the last part, and question number 6 is done.